Welcome to our first question, and Sean's with us today. Sean, can you, if you want to say a few words about yourself, and then we can start with the question.
Hey everybody, my name is Sean. Greg and I were roommates in college, so that's how we knew each other.
Embarrassing
And
stories,
yeah,
right?
excited for this
No,
challenge.
no need for any embarrassing stories.
There's plenty.
Okay,
So, ready to get down into
Yep.
it? Okay. So start out with a easy one.
Yeah, I mean, I
Easier one.
easy one.
And just let me know if you've done this question before.
Mm-hmm.
Let's see. Given two singly linked lists, determine if the two lists intersect.
Okay, so I'm given two singly linked lists.
Correct.
And I have to determine whether they intersect.
That's right.
So how would you define an intersection of two singly linked lists?
How do you think?
So you mean
two singly linked
So I
lists?
assume, so if this is a singly linked list, right, and each circle is a node, if they would it be something like this? So if they point to the same node at one point, is that what you mean by intersection?
Yes.
Okay. So determine whether they intersect. So, and so let's talk about the constraints first. So I assume that we're given two nodes representing the start of the two linked lists, right?
That's correct.
Okay, and then and can I assume that they're valid nodes, that they're not null?
Yes.
Okay, so they're both valid, and the linked lists, can I assume that they eventually end? So so there aren't any circular nodes, circular linked lists.
Yes, they're all singly linked without circular.
They're guaranteed to end at some point. So
yeah.
If I traverse from the beginning of the node, one node at a time, the beginning of the linked list, one node at a time, then eventually I should get to a point where there's nothing, right? It doesn't point to anything, and I know that's the end because there's.
Right.
Okay.
Yeah.
So. Okay. Right now, I don't know how long the linked lists are. But I'll say they're of length. Assuming if I have two linked lists that do not intersect, then I will assume that they're of length m and of length n. So there are m nodes in the first one and n nodes in the second one. So I'm going to come up with an example. So that is one example. And another example would be what I just described. So where they intersect. Let's see. I'm trying to think of other cases that I haven't described yet. So I can't think of any right now. So I'm just gonna start with this. So
Mm-hmm.
to see if they intersect, I would have to. Well, I would have to start at each. I have one idea. So I would start uh, by remembering. I would start at the top of each linked list, and I would go down one by one and see whether they're the same.
Mm-hmm.
Well, actually, but sorry. Let me come up with a more a larger example. I guess that's what I mean. Okay, so let's say we have something like this. Um, Originally, I thought I might just start with at the top of each list and go down one by one, but then I
Okay.
see a problem because if I do that, then if the lengths of the lists aren't the same, then I could miss one, right? I wouldn't end up at the intersection at the same time.
Right.
So I can't use that. Let's see. Uh, I only have I only have access to the start, the starts of the lists, but I wouldn't be able to backtrack because it's singly linked. Um, I suppose one way, but not the most efficient way to do it, would be
Mm-hmm.
when I go through each node, I would push it to another. Uh, I would store that node somewhere. I would remember that I've seen it, and then I would start
Mm-hmm.
at the other list and do the same. And for every node I go through, I would with check to see if I've seen it before. But the
Uh-huh.
problem is, well, to traverse, well, to store everything for M, I guess I would take um, OM time to look through each node and store it.
Mm-hmm.
But
What data structure would you use to store
right,
it?
so I would probably use a hash map for that because I don't know how many elements there are, so I don't know how much space I have to allocate to it. So if I,
Okay.
yeah, um, and then when I check, I would actually have to uh, go through n times. Uh, the worst case is m, right? So I guess it would be so the time would be n times m.
Mm-hmm. Like, can you repeat that again?
Sorry, so the time complexity would be O and M, assuming n is the length of one linked list and m is the length of the other.
N times N?
M n times m.
Okay, so you're saying for the hash tables, storage on the initial traversal to store the references of these, that would be.
So the storage itself would take constant time.
Okay.
But the storage complexity would be, well, since I have to store every element of one of the lists, it would be either OM or ON, depending on which.
Right.
Yeah.
Right. Okay, and that total algorithm would be n times n,
It would
including
be,
the storage and the lookup.
so it would take. Okay, so let me move this down a bit. Okay, so the storage would take OM time to store everything in the hash map.
Okay. Yep.
And then when I look through it, I would have to do O n times m comparisons, right? For each of the n nodes, I would have to look through m elements. I would have to look through all of the elements in the hash map to see. Oh, actually, if I'm doing that, then I don't need a hash map because I could actually just loop through the list every time to compare each node. So,
so using I think you were on the right track for the hash map. That's definitely a valid solution. For the lookup for the hash map, you already can get a hash of your matching portion, right? So the first iteration you are storing m, and then second iteration you are matching each node in n. With each node in n, you don't need to search through the whole hash map because the hashing does the quote-unquote search for you.
So let's see.
So what happens to, let's say you have a, let's assume these are unique integers, right? In n and m.
Yeah.
So you can search by their value, node of the value.
I guess in that case, I should ask more about the constraints. So in these nodes, are there any repeating values?
In the original question,
yeah,
I would say yes.
Okay.
I think for now, might be slightly easier to think if it was unique. So I'll make that a follow-up. So right now it is unique.
Okay. And then these, are they in sorted order or not?
They're in no particular order, so unsorted.
Okay, so if I can just check, and can I assume that if they're pointing to, say, this node, can you see what I'm circling? Okay, so
I'm actually quite zoomed in on the on the stream.
Okay, so the intersection, right? If say the value of the intersection is 5, can I assume that there aren't any? Okay, so I'm saying if there is no intersection, then can I assume that these two lists have no common elements?
It's a good question.
Because
yeah, let's assume that for now.
Okay. Yep. Okay. So in that case, I guess in order to see whether I've seen the element before, I would just store it in the hash map, and I would store each element that I've seen for one of the lists in the hash map. And then in the other list, I would go through each element and I would look at its value and see if it exists in the hash map. And that wouldn't take O and M time. That would actually just take O. It would be a constant lookup for each for n elements. So actually, so let me change that. That would be actually O n for the lookup, because you're looking up n elements, and in total, that would be O n plus m, and we can't say it's just O n or O m because we're assuming that these are different lengths.
Yep. So that is one solution. Certainly the lookup is quite efficient, but we also need to consider space.
Oh, right. So space would also be OM, because we're only storing the elements of one list.
So what if I told you not to use any linear space or data storage for it?
Sorry, Sean, I'm going to have to interrupt you because I need to run up and grab my charger real quick.
Okay, go ahead.
Okay, I'm back. Let me just plug this in. Right. Okay. Sorry. Can you say the last thing you said?
Yeah. So using the hash map algorithm, we've determined time complexity is m plus n.
Yeah.
And space complexity would be
OM.
O of m.
Yeah.
Do you think of an algorithm that uses constant time space complexity?
Constant time and constant time and constant space. So
only constant space. So time would.
So without using any additional space, you're saying?
Sorry, can you say that again?
You're saying without using any additional space, right?
Yes.
And the time, and I would, and still use O n plus m time.
Yeah.
Okay, so let's go back to what we had before. If I don't store it,
Oh, by the way, can you see if you can zoom out on the whiteboard? So I only see almost half of your computer.
Almost half of my computer.
Yeah. Your window stops from the Apple icon to the Dropbox icon.
Oh, really?
Yeah, I wonder if you can zoom out a little bit. Or you can zoom in the window.
I don't
know, that would be helpful.
Oh. Okay, damn. Okay, I don't... Let me see. I guess... Well, it's already set on no crop. Oh, I see what I see. Okay, because it was maximized. That's why. Should it is it getting better?
That became worse.
How about now?
Yep. Wait. Go back again. Okay. That's.
You can see.
Keep going that way. There we go. Okay.
Okay. Yep. Sorry for all
perfect.
the interruptions.
Yeah. Sweet.
Okay. So if I don't store the values, I need a way to know that I've seen them before.
Mm-hmm. So how would you? I think that initial idea that you had, in which you had two fingers, each one pointing to the head of the node.
Yeah.
I want you to go in that direction.
Okay.
And like simultaneously matching each next node.
Okay. So let's look at this diagram again. Let's use a different color. So if we have 2 pointers, or I mean, we just keep a reference of 2 nodes, one on each list.
What's the problem with this current iteration right now?
Well, because if I keep going one by one, then so this would be, so let's say this is my first step, and then this would be my second step, right? Second step, third, oh sorry, second step. So first step, second step. Here would be this would be the first step. This would be the second.
Oh, you missed the two. Two is on the lower one. There you
go. Oh, well, I mean, if I start with this, sorry, it's all right. Maybe I should clean this up a bit. So is this better?
Yep, that's better.
Okay. So, and then so let's say I'm on my third step, and so here I would on the left I would say this is my third. I would be moving to this third node, and on the right this would be my third node. And then when I go to the next node, oh, actually I have an idea.
Okay.
So if I don't need to know where I am. I don't need to know, since I'm only trying to find out if they intersect. I'm not trying to find the intersection, right?
Yeah.
Okay, so if they intersect, that means they would eventually end up at the last node, right? At the same node. So I don't need to worry about them missing. I don't need to worry about the fingers missing each other, because, so let's say this was 4, and this is my 4th node on this side, on the right. And then, when this is the 5th node, this would be the 5th node on this side. And when I reach the end, I would just stop and wait until both fingers point to the last node of their lists, and I would compare those two to see whether they're the same or not. And if they're the same, that means they intersected. If they're different, that means they didn't intersect. And basically this would just be a traversal. The complexity of this would just be a traversal of the left one and the right one, right? So that would just, the time complexity would be n plus n, but you wouldn't have to store any additional stuff. And do you want me to try to optimize it further?
Um, I'll step up the difficulty and say you will need to find that intersection.
Okay.
Yeah, but this is part of the way there.
Um. Okay, so let's see, if I need to find the intersection, what other information do I need? I can't just,
Mm-hmm.
so
So what's one case that these will work if you do the 1-1 kind of strategy?
where it won't work?
Well, it will work.
Oh, it will work if the nodes, if the lists are of the same length, because that would mean, after they intersect. So after they intersect, which is here, they're essentially the same.
Okay.
So that would mean they're the same length there.
Yep.
And then if they're actually at the same length, that they would have to have the same length before they intersect as well. So that would mean they would intersect at, well, we would reach the intersection at the same time.
Is there a way that you can determine the length of a linked list?
So can I say what gets passed in as input? So could I say that the linked list keeps a record of how long it is?
Not required. I think that would be a little bit more complex. Are you saying in the input it'll tell you how long the linked list
Let's
is?
say, for each node, can I keep track? Can I keep two or keep three things? One's the value, and one is the pointer to the next node. And then one is how many more nodes are connected.
No. So, well, how would you know? How would you just determine the length of any linked list?
I would have to do a traversal, right? Starting from the beginning until I reach the end. So that determining the length would require either OM or ON time. So, or I guess OM plus OM plus N to determine the time. To determine the length. And then, okay. So once I determine the length, I just need to, so let's say I know that M is of, say, 1, 2, 3, 4, 5, 6. So the length of M is 6. And the length of N is 5 in this case. And so I want to start at where they're at the same distance from the intersection. So here, I would just find the difference between these two numbers, and I know that M is longer, so I would start at M first, and I would move down one node first, and then once I'm at the same distance from the intersection, I would just go down one by one until I find the intersection, until they're the same. And if they're not this, if there's no intersection, then they would never be the same, and that would be it. And so I would take OM plus N to determine the lengths of the two lists, and then also m plus n to find the intersection. And because we can eliminate any constants, the running time of this would still be m plus n.
Mm-hmm. And what would be the space complexity?
The space would also, well, the space would be constant because, well, you need to store the lengths of the two lists, so that the space would be this, because
Mm-hmm.
yeah, it's a constant times 1, so it's O1.
Okay. Cool. Let's go with that algorithm.
Okay. So I guess the problem solving part is okay. So do you want me to code it out?
Yeah, let's code it up.
Okay. So okay. So let's see. We have. Sorry. So this would return. So which version of the algorithm am I doing? So the final one, right? So I want to return the intersection of the node.
Yep. Do return the more efficient one.
The more efficient one.
Yep.
Well,
in terms of big O, right? So it's worst case. It's not always going to be faster, but at least theoretically, on a big endpoint, it's faster.
Okay, so I want to find the
faster / more space efficient.
I want to find the intersection. So so I would define a method, and what am I returning? Am I returning the value of the node, or
you're returning the reference of the node?
Okay, so
so you can just assume that there is a data structure called node,
okay,
and it had the behavior of a regular, singular linked list.
Okay, so I'm going to assume we're returning this thing called node, this object called node, and then we're passing in. What we're passing in is 2 linked lists, which are essentially we're passing in the nodes of the heads. So
let's do node.
I'm gonna say, can I say node m and node n?
Sure, that works.
Okay, so so let's see.
And what language would you be programming in?
I would be doing this in Java.
Java? Okay, let me change the syntax.
Oh, okay.
Yeah, you can do it on the side.
Plain text. Oh, great. Okay. Perfect. And I guess I don't know whether we're doing public or private, so I'm just gonna leave this.
Sure.
Okay, so first we want to do a traversal and find. Let's see. We want to find so int length of m is, I want to find the length of these 2 lists. So find length of m. Actually, I'm going to change it to lowercase so that it's consistent. And the length of n would be this. And then what I want to do next is I want to traverse through both lists. So I would start, let's see, I want to see which length is longer, and I want to reduce that accordingly. So so I think I'm going to do this. If length of m is smaller than length of n, then otherwise, and if they're the same, I don't do anything. So if length of m is greater, then what I want to do is find their difference, right? So their difference would be length of m minus, length of n minus length of m. And so once I have the difference, I want to iterate that many times. So I would use a for loop for int I equals 0, I less than if I plus n. What I would do is, I guess I should have made this into another function, but all right, let's.
What you could do is have two different references of lists, and one called longer and one called shorter. And you can just kind of hot swap them depending on which one is longer.
Yeah. So I think I'm going to define that in another function.
Okay.
But what I'm going to do is, what this function does is, well, I'm going to pass in the two lengths and the two nodes, and it's going to return two lists that are the same length. So or maybe not. Sorry. So yeah. Okay, so I'm gonna find which is the longer node. So, no, what am I doing? Sorry.
Take your time.
Yeah. Oops. Okay. So I guess what I want to do is I want to find the longer list, and I want to reduce it accordingly. So longer list like this. Node okay, no, that doesn't. Oh well, okay, so find the longer list, right? And I would pass in two nodes. Maybe I should just do it the long way.
Sure, or whatever works for you.
Yeah. So okay, so no, I think I'm a little stuck on this. Like I'm trying to modularize it, but
Yeah. So you already have find length that tells you the length of each. You could do a if else, and then just do if m is longer, do this. If n is longer, else n is longer, do that.
And
or you can compare the lengths and then put in for longer to shorter.
Okay, so maybe I'll just do a comparison.
Yep.
So this is I want to see whether one is longer than the other, or if they're the same. If they're the same, I'm just not going to do anything at the end. So I'm comparing whether m is longer than n, or n is longer than m. And if m is longer than n, then I want to find a difference. Actually, let me declare this out here. The difference would be and in the same way I would just be finding the difference if n was greater than m. And then if m is longer, I want to reduce it. So use a for loop, I guess. And I would want to do this however many times the difference is. So and then m would be equal to its next node, and I assume there is a method called next in the list. Okay, and then same way I would do this for n, but here I would change it to refer to the n list rather than the m list. So after doing this, I should have two lists that are the same length, and they might or might not intersect. So what I want to do now is go through each list, go through both lists one node at a time, and see whether those nodes are the same. And so, I should probably have. Okay, so I guess I want to okay, so let's do a while loop here. While and because these lists are now the same length, I only need to look at one of them. I don't need to look at both of them. So I want to make sure while the next one is not null.
Okay.
While there still is a child. While n is not equal to null. So I would go through this one by one. If they're the same, then I would return. So if m equals n, if they're the same, then I want to return. Well, if they're the same, then I just return the same one of them, and it's the same thing. Otherwise, I'm gonna iterate through them. So basically, m would be its next node, and n would be its next node. And let's see if that. Oops. And let's see if that works. If you're okay, so I'm going through each node one at a time. If they're the same at any point, then I would return that node. Otherwise, I would just keep going to the next one.
Mm-hmm.
And um, if I reach the end without finding a match, then I just return null. I assume we want to return null if there's no intersection.
Mm-hmm.
Yep. So that's, and yeah. So for the find length method, I can implement that as well if you want. But I think it's, I mean, we're just going through each element until we
Mm-hmm.
find the end and recording the length of that.
Yeah. Cool. Yeah. So this is I guess where I would stop you in the actual interview. And yeah. What do you want to do now? Do you want to kind of go over feedback or?
Yeah. I would. Yeah. I mean, I do feel like there were quite a few places where I just wasn't very comfortable, but I was busy thinking about the problem, so I didn't have time to mark down
Mm-hmm.
what I could improve on. So
Okay.
yeah.
Let's look at the code first.
Mm-hmm.
I think overall it's solid. It probably will work.
Mm.
If you throw it into a Java program.
Yeah. So
Even though
one thing about that is I know we're supposed to pick a language that we're most familiar with, but um, I am I feel like I'm not familiar with any of them. So I picked Java. Um, I think that's the right syntax, but
yeah, it is. It is.
okay.
Yeah. Yep. I think everything looks good so far. Um, I think this is really good for interview. One thing that would kind of blow me away would be the duplicate code for the if else.
This part, right?
Yeah.
Mm.
So one thing you could do, I don't know if I type on here.
Ooh, okay. Yeah.
So you can do something like,
So I should work on
restore.
modularizing.
Sorry.
I should work on modularizing whenever I can, right?
Yeah.
Because that would actually simplify the code and make it easier to follow, and I wouldn't have to. It would be simpler, I guess, and maybe I could skip some of the stuff that doesn't need implementing.
Yeah. So you can probably do something like balance longer list,
Mm-hmm.
and then do um, equals trim list dot uh, and I don't know if you're familiar with this syntax. This is a quick comparison and then a true false statement. So LM is greater or equal to LN. It is pass in LM. If it's not, pass in LN.
Okay.
I think we saw this
Mm-hmm.
a little bit for our older projects.
Yeah.
So that would be the first variable. The second variable would be the difference here. So the difference you can probably do like absolute Math, not absolute ln
Okay.
minus ln, something like that.
Okay.
It's a little bit convoluted.
No, I understand. Yeah, I got it. So, right. So the first argument would be the greater length, and then the second argument would be the difference. Okay.
Yeah, and if it's 0, it would just return it.
Hmm.
So this one line, even though you'll have to implement it, at least it's always implemented once or written down once.
And I think for that we would probably have to pass in the two nodes as well, right? Or one of the nodes.
I just think one of the nodes.
Yeah, one of the nodes, the longer one.
Right. So this would return the longer node, but starting at the right position. Or obviously there's many ways to do it.
I think we could reuse this part actually, lm greater than ln, and then so maybe like this. So I'm copying it. So let's say we have a third argument, and then instead we pass in, if m is longer, we pass in m, otherwise we pass in n, right? Hello?
Oh. Yep. No, you're right. You're right. Actually, the first variable was for that.
Oh, right. Oops. Yeah.
Yeah, I just had a typo.
Okay.
That was my mistake. Yeah.
Also mine for completely missing the point. Okay. Yep.
Yeah. So I think everything else is solid. Let me take a look at the charts or your graph.
Oh,
graphic.
So.
Yeah, I don't have any complaints. I think your process was good. You drew examples. I was a little bit afraid in the beginning where you
took a
drew
bit
this
of time,
example,
right? Huh?
the first one, because they were the same length.
Right.
Yeah, that would be like a special case, right?
And we want to try very hard to avoid special cases.
Right. At least for your first example. It's always good to visit a special case, but starting one can lead you down a longer path.
Do you think?
Yep. Go ahead.
In terms of time, I guess I probably spent too much time on just one problem on this. Do you think how would you tackle that? How would other than just practice? I mean, I'm going to practice more, but is there any other approach that would be more efficient for me?
I think a lot of it's on the interviewer to kind of push the question along. We took a total of about 40 minutes for this question, which isn't bad for a first time. I'd say it's a great start.
Was I asking enough questions, or was I asking the right questions? Do you think?
I think you were asking good questions. One thing you could do is to determine the space and time complexity faster, and I feel like this is something you'll get with much better with more practice. You say, oh, hash map, you need to store n elements, but lookup is n, and just kind of jump to a lot of this is all intuitive as well. For the second question, it was kind of a hit or miss. The second part where I had to count the actual lengths. It's like, for me, when I worked on this question, it was just like, oh, it suddenly clicked, right?
Yeah.
And
I think when actually when it clicked for me, what I was doing was I was actually walking through the example. So I think, and before I didn't do that. I was just
Mm, okay.
generalizing. So maybe it helps to walk through it um, early early in the question. Maybe even
Yeah.
without doing it. Maybe even without coding. Maybe just by um, like doing it as a non-coder would do. I think.
Yeah. Yeah.
So.
Um, yeah. I actually asked this question to Elizabeth too,
Hmm.
um, and she figured it out after a while. So it's kind of cool
I
to
didn't know
see a
she was also a
non-coder kind
coder.
of go through this process.
Mhm. I didn't know Liz
Um,
was also CS.
hmm?
I didn't know Liz also did CS.
She did not. She does
Oh,
not.
okay.
She did take a slight computer programming class.
Hmm.
Um, but yeah, I think everything was complete.
Hmm.
It did take a little bit longer, but I think it was complete, which
I
is
feel a
the
little
important.
better then.
Yeah, no, it was good. It was a good start.
Hmm.
Cool. So
Okay.
I guess that wraps it up for your portion of this
Yep.
interview.
So that is our first question, and I know you said you had to leave
Yeah,
in
I should
10:45.
run in like 25 minutes, so
Okay.
we can
So
probably just get started on the question, and then we'll see where I go. Maybe I'll like figure it out throughout the day.
okay. So why don't what I'm gonna do right now is I'm gonna stop this session, and
Hmm.
then we can start the next one, and I'll explain. I'll go through the question with you until you have to go, and then we can pick up where we uh, stop. Okay. So
Sure.
let me stop this now.